Hello and welcome to today's video. Today we're going to be taking a quick look at how to store data with the microcontroller. So today we're going to be using the Arduino Nano, but we're going to be storing the data using a SD card. So there's a few things, before we jump into it, there's a few things to understand. First of all, there are file formats. Now, if you've not really taken a look at Windows PCs before, you need to understand that there are 3 or 4 different file formats. There's something called a FAT16, which is a 16-bit FAT addressing scheme, which can support up to like a 2 GB memory card. Then there's something called FAT32, which is a 32-bit system, which can support memory cards, I believe, up to like about 32 gigabits of data. When you start getting above a 32 gig memory card, Windows can't use the FAT32 file system. It starts getting onto like an NTFS and different file systems. Now, the technique and the drivers that we're using today will only work on the FAT16 and the FAT32. So with today's video, we will be limited to a 32 gigabyte memory card, and I've got a few here, but 32 gigabytes should be plenty. As I say, considering the amount of data you actually got on the memory on the microcontroller itself, 32 gigabytes should be enough. With that said and done, I'm going to quickly jump over to, well, let's go over to the breadboard first of all, just to take a look how I've got it hooked up. So here we can see we have the circuit board. Now on the left here we actually have the Arduino Nano. Down here I have the SD card module. This module isn't so much a module, it's basically just the SD card holder with a couple of capacitors and a couple of resistors. The module claimed it had level converting on it, but as far as I can see, it doesn't. It may have a current limiting resistors, but it's not really doing level adjustment, and that's important to understand. So the Arduino Nano is powered and its digital lines are 5 volts. So the way we're going to communicate to the SD card is through the SPI, the serial peripheral interface, okay, which is a industry standard interface. But the data lines coming from it, we need 3 lines. Well, we've got 4. We have the clock, which is this yellow one, pin 13, and the MISO, master in, slave out, and the master out, slave in. And then there's a chip select pin. Now, coming out of the Arduino Nano, they are going to be 5 volt signals. This is going to be fed directly to my SD card. If you look at the specs on SD cards are 3.3 volts with a 3.6 volt maximum. So I did not want to risk taking a 5 volt signal and shoving it into a 3.3 volts. You might not get any smoke, but it might not work. So to fix that, what I've done 2 things. Down here at the top on the right hand side, I have, let me see if I can zoom in. Okay, that maybe make it a bit clearer. At the top here, I have 4 channels of a level converter, which converts between, on the left side, which is my 5 volt side, to the right side, which is going to be my 3.3 volt side. Okay, so these are just the level converters, and I've got, as I say, 4 channels, because as I've just mentioned, we're going to be using the clock, the MISO, the MOSI, and a chip select. which, surprise, surprise, is why these modules typically have 4 channels. So all we need to do is reconnect ground and 5 volts on the left, and then we connect up the data lines. And then on the right, we connect up 3.3 volts and ground and the data lines. In fact, we actually don't need to connect up the ground on both sides, because the ground actually is common across the level converter module. So ground on the left is connected through to ground on the right. Now, the only other thing I needed was to get a 3.3 volt supply. Now, the Arduino Nano does have a 3.3 volt supply, but it is maxed out at 50 milliamps. When we are communicating to the SD card, this may draw up to 200 milliamps. So I cannot use the 3.3 volt supply from the Nano module. So to fix that, I have just added up here a little MCP 1700 low dropout module voltage converter. This one can easily take the 5 volts from which I'm taking from the USB line. So I take 5 volts from the USB. So I've got plenty of power on that line. I then feed it into the MCP 1700 voltage regulator. I need 2 1 microfarad caps for stability, which are these here. And then this outputs a nice 3.3 volt regulated supply up to a maximum of 200 milliamps. It can peak at, I think, 250, but in reality we only need 200 milliamps maximum, and only for a split period, a split second. Most of the time this is drawing almost nothing. And that pretty much is the configuration. So Arduino Nano, so I've got the 5 volt output and the ground coming across to my level converter circuit, and then I have the data lines from the Arduino Nano coming to the HV, the high voltage side of the level converter. I then have the data lines from the low voltage side going through to the various pins on the module. I have the SD card inserted, and then all of this side is powered by the microchip 3.3 volt voltage regulator. So it's a very simple circuit really, but it's just a little gotcha is to make sure you put the level converter in there, because you really don't want to keep blowing up or burning out the SD cards, because they really are limited to 3.6 volt absolute maximum. Okay, so with that said and done, let me just power it up. Okay, so I powered it up, and let me zoom out a little bit. So just to confirm that I'm getting 3.3 volts. Make sure you can see it. So we're getting a nice 3.3 volts there. So with that said and done, let's look at the software. Okay, so before we get started with using the SD card, we need to install a library. The library I've installed is this SD by Adafruit. Oh, sorry, SD by Arduino Spark Fun, and it's version 1.2.4 is what I've currently installed. And again, a lot of these modules and libraries are great. So I installed that. And again, if you look under examples, under SD card, we have read and write files. Okay. So we have the pins that are currently assigned. If you're not using the Arduino Nano, make sure you check this. In fact, the chip select pin, I'm not using pin 4, I'm using pin 8, so I'm going to need to change that. So I change that from pin 4 to pin 8. So as I said earlier, we're using the SPI interface, so you need to include the SPI library, and we're using the SD library interface as well. So pretty much it's very simple. We use this file to create a variable, my file. Then we use the SD to actually begin. And again, you pass in the chip select pin. The way the SPI works is you can have many different SPI devices on the bus. And basically, but each one has a chip select or an enable or select. It's amazing. Every manufacturer has a different term for chip select, so don't be afraid if it's called something else, but there'll be something to enable the device on the SPI bus, and then all of the other devices on the other SPI bus but go basically into a tri-state mode where they're not affecting anything else on the bus. So we have the begin, then we have a method where we say open file. Now, I've already run this a few times, so the way this works is it creates a file called test.txt, and it sets it for write, and they're the options, and then it goes if file, and then you go my file, and then basically it does like the serial command. You can print to the file, then you say close the file. It says done, and then in this bit of code it goes okay, it then reopens the file if it can, and then it goes my file available while there's data available, and it goes my file read. So all we do is basically we open the file, and then while it's available, we're going to read from the file. And then this is going to read the entire file and print it. So it's not like reading a byte or whatever. It's reading, in this statement, it's going to read everything, and then it's going to close the file, and then as long as that's worked, we finish. Otherwise, it's going to print an error. So let's try and just upload this sketch. We're going to look at the monitor and see what happens. And there we go. So writing to text file is done. Now, as I said, I've run this a few times, so it's written the statement now 1, 2, 3, 4, 5 times. So it keeps appending to the text file, and then the final statement reads from the file, and it's done. So just to prove 4, 5, make sure it's actually reading. Now, if you wanted to do a different file, all you could do is give it a different file name, test2, right into test2.txt, opening test2.txt, open test2.txt. Okay. clear that. And there we go. So now what we've done is, because we've changed the text file so it's now empty, it's created a new text file, test2.txt, and then it's open test2.txt, and it's printed out what we wrote into it. And it's as simple as that. Now, there are various other printing functions, reading functions. So my file dot, okay, so you can read and write that. So instead of actually just printing, you can do things like read bytes. So if you didn't want to use a text-based system, you can actually yeah, it's annoying. This actually isn't. I thought this was actually. It is. Oh, it is. Okay. No, it's not. Sorry, I thought this is alphabetical, but it's not. Or is it? A-F-I-S-P. No, I thought this was alphabetical, but it's not. You got C after P and F. That's a bit annoying. I thought it was. Okay. Anyway, so the only variance is basically to be able to read bytes and write. I'm guessing you can. Yeah, so you can write bytes as well. So if you wanted binary data, all we'd do is write, and then you'd pass in whatever binary data you wanted, and then you could read it as bytes, or you print it as text. So it's an incredibly simple interface, but it gives you very quickly and very cheaply, as I said, I believe the the holder for the SD card was, I think, $1, and the level converter was $1. Actually, the most expensive thing probably is the voltage regulator, which I think was $2. So for $4 plus the SD card, you can get 32 gigabytes of storage and hook it up to pretty much anything that you want. In this example, I'm using, as I say, the Arduino Nano, but the same technique will actually work for a microcontroller from Microchip or any other devices, as long as they can support the SPI interface, either via hardware or by bit banging. You can easily hook up the SD cards, and as I say, it's an incredibly good way of storing large amounts of data. As I say, the only limitation I could potentially think of is if you wanted to shove it into a rocket for telemetry. Under acceleration, the SD card may come loose. So that's about the only application I could think of which you might want to consider using a more solidly soldered EEPROM or something like that. But for storing data, audio files, and vast amounts of log data, it's incredibly easy and incredibly low power. The Microchip voltage regulator that I'm using has a very low quiescent current draw. The level converters are MOSFETs, so again they are very low power. And yes, the SD card reader does take 200 milliamps when it's writing, but it only does that for a split second. So again, there's no reason why you couldn't use that same approach for a battery powered application. Anyway, hope that's of some use. I'm going to finish the video there. And in the next video, I'm going to be looking at the EEPROM. So if you're interested, please stay tuned. Okay, thank you for watching and have a great day.